This will be for the con exercise, trig values of pi over 6, pi over 4, and pi over 3. So I like to convert these to degrees first. Okay, if you recall, pi in radians equals 180 degrees. So to convert these to degrees, 180 divided by 60 is actually 30 degrees. 180 divided by 4 is 45 degrees, and 180 divided by 3 is actually 60 degrees. So that is the conversion for each one of these trig values. All right, it says the angle measurements of this triangle are in radians. What is the value of sine of pi over 6? Enter an exact value or round to the nearest hundredth. Okay, of course you can easily do these on the calculator, but I'll show you the way they want you to do these. All right, so for many of these problems, they want you to construct an equilateral triangle. So that is all three sides and all three interior angles congruent. So we know the triangle interior angles, they add up to 180. So if all three are the same, each angle is going to be 60 degrees. All right. Now, if you draw an altitude, or let's just say you draw a segment that bisects this angle right here. So instead of 60 degrees, we will have 30 and 30. Okay, if this is 60 and this is 30, this one here has to be 90. And same thing on the other side of the triangle as well. This would have to be 90. And as a result, we actually have two congruent triangles. Okay, the one on the left and the one on the right are congruent. We can say that by angle, side. All right, this side is shared by both triangles. We can mark it congruent. The 60 matches the 60, and the 30 matches the 30. Okay, so the one on the left matches the one on the right by angle, side, or AAS. As a result, this base down here is bisected, so this side is congruent to this side. All right, and since if you look at the overall triangle, all three angles are 60, that means all three sides of this triangle are congruent. So let's say, for example, this side was X, this side would also be X, and this entire base would be X, and then each of these would just be half of X. All right, so this is what they want us to use for these problems. All right, in addition to that, you want to be familiar with the basic trigonometric formulas. SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And finally, you want to be familiar with the ratios of the side lengths of special right triangles. Okay, for the 30, 60, 90, if you go across from 30, let's say that side length is 1. Across from 60, it's going to be radical 3 times bigger. Across from 90, it's going to be 2 times bigger than the side across from 30. For the 45, 45, 90, the sides across from 45 are the same or congruent, and the side across from 90 is radical 2 times more than the sides across from 45. So you need to be familiar with special right triangles first. All right, so let's look at the first one. Okay, I can't do these with radians, so I always convert it. So pi over 6, that's 180 over 6. This is going to be 30 degrees. All right, so let me erase this here. All right, if this is 30 and this is 90, then this is going to be 60. Okay, and we basically want to construct an equilateral triangle with all 60-degree angles. So I'm going to draw another triangle right here that's the same as this. All right, so if I extend this right here and draw this in right here, Okay, remember this angle is bisected. If this is 30, then this is 30. If this is 90, of course this is 90. 30, 90, this has to be 60 right here. Okay, and now we can label the side lengths. If you look at the big overall triangle, we have 60, 60, and 60. So all these sides are congruent. If this is 12, this is also 12. This is 12 right here. So divided by 2, this is going to be 6 and 6. And let's see. All right, they asked us for the sine of pi over 6. But we converted that. So that's just going to be the sine of 30 degrees. All right, and remember SOHCAHTOA, for the sine function, it's opposite over hypotenuse. Okay, so we have to look at the 30 degrees, go to your opposite side, that's 6, and then go to your hypotenuse, cross from the right angle, that's 12, so 6 over 12 is just 1/2. I'm going to try to enter this. I want to see if they make you reduce the fraction. So I'm going to try 6 over 12 first. All right, let's see. 6 over 12. What happens? Okay, they actually accept it. So apparently you don't have to reduce. They just say enter an exact value or round to the nearest hundredth. Okay, so we have our triangle in radians, and they want the tan of pi over 4. All right, I think this one is easier, and that is because pi over 4 is just 45 degrees. So if you don't mind, I am going to erase this and make it 45 degrees. Okay, if this is 45 and this is 90, then this is 45 right here. All right, so across from 45, we have 12. And within the same triangle, if you would go across from the other 45, that also has to be 12. Okay, so this one is easy. We don't need the hypotenuse because they just asked us for the tan function. They asked us for the tan of pi over 4. Okay, and that's 180 over 4. So that's the same as the tan of 45 degrees. All right, if you recall SOHCAHTOA, for the tan function, it's opposite over adjacent. So if you look at the angle being referenced, you go across, that's your opposite, so that's 12. Over here, this is your hypotenuse, so the remaining side has to be your adjacent. Okay, so it's just 12 over 12, which of course is 1. All right, so that's it. Pretty easy. This one is just 1 right inside the box. Okay, right here we have a partial unit circle. All right, you can see the radius here is 1. Anyhow, they want the coordinates of point A. If you recall on the unit circle, the x-coordinate is going to be the cosine of the angle theta, and the y-coordinate is the sine of the angle theta. Okay, this is just a Greek letter theta representing the angle measurement. The angle theta has to be made with, let's see. The angle theta has to be made with one of the axes, okay? So you can see here, this is the x-axis, and this angle right here, and going counterclockwise, is pi over 3. Okay, once again, I don't like to do these in radians, so I'm going to convert it. Pi over 3, or 180 divided by 3, is just 60. So I am just going to erase this and fill in 60. Okay, if this is 60 and this is 90, then this one here has to be 30. All right, and for the unit circle, the radius is always 1. So this is also a radius. Here's the center, and it goes to the circle. So this is also going to be 1. Okay. Recall the ratio of the side lengths for 30, 60, 90. That's going to be 1, radical 3, and 2. Now you can see the one across from 90, it's just 1, it's not 2. So we have to cut each one of these in half. So divided by 2, that's 1. Divided by 2, that's going to be radical 3 over 2. And divided by 2, that's just going to be 1/2. All right, because this is the ratio for the 30, 60, 90 triangle. But the one across from 90 is not 2. The one across from 90 is just 1. So 1 is half of 2, and I just took half of the other ones. All right, so the one across from 30 is going to be 1/2, and the one across from 60 is going to be radical 3 over 2. All right, and now it's easy. If this distance is 1/2, this is the x-axis, so that's going to be the x-coordinate of A. And if this distance vertically is radical 3 over 2, that's just going to be the y-coordinate of A. So that's it. We actually didn't need to do the sine and cosine. All right. So on the unit circle, the x-coordinate for that angle is 1/2, 1/2. And then the y-coordinate, click the square root button, radical 3, hit the right arrow key, /2. Okay, so in this case, I got radical 3 over 2. All right, cosine of pi over 4. So pi over 4, we said it previously, that's 180 over 4. That's actually just 45 degrees. All right, so this is a 45-degree angle. This is 45, 90. This one here is 45. Okay, so going across from 45, that's a 3. Go across from the other 45, that's also going to be a 3. And recall for 45, 45, 90, the ratio is 1, 1, radical 2. Okay, the ones across from 45 are the same. The one across from 90 is radical 2 times more than the other ones. So if this is 3, the one across from 90 is going to be 3 radical 2. All right, and once you have your side lengths, it's pretty easy. All right, this one here was the reference angle. So you go across from 45, that's your opposite. You go across from 90, that's your hypotenuse, and the remaining side is your adjacent. Okay, we are dealing with cosine. So you just want to remember SOHCAHTOA. In this case, cosine is adjacent over hypotenuse. All right, so cosine of the angle theta is going to be adjacent over hypotenuse. So we are looking at the cosine of 45 degrees. And that's going to be adjacent, which is 3, over hypotenuse, which is 3 radical 2. The 3's cancel, and it's just 1 over radical 2. Okay, Con accepts it like that. If you want, if you don't want the square root in the denominator, you can just multiply it by radical 2 over radical 2. You take the denominator and multiply it over itself. 1 times radical 2 is radical 2. Radical 2 times radical 2 is just 2. So you could do this, but they actually accept it with the square root in the denominator, so I don't do the extra step. Okay, it's just 1 over radical 2. So you click in the box, and I type 1. You can hit the fraction button or the slash, and radical 2, okay? 1 over radical 2.